Hello everyone, and welcome back to the radio shop. Today on the bench we have another repair for you. We have a Yaesu FT2800M. This is a FM 2 meter transceiver. But before we get into the video, I might make a little shout out to another channel. And that channel would be to TheDefpom. And if y'all haven't seen any of his videos, I'll leave a link down below. He's currently hit 600 subscribers, and he's doing some great stuff, electronics, repairs, dash cam, some music, and a few other things. So if you haven't looked at his channel, hit the click the show more tab below. I'll leave a link to it, and you go there and check him out. He's been doing some reviews on some signaling equipment. Siglet has been sending him some stuff to do reviews on, so check it out. And we'll go ahead and get into the repair video of the Yaesu FT2800. What we have on the bench is a Yaesu FT2800M FM transceiver. And one of the viewers had emailed me, and today I had the radio and decided to go ahead and put this one. He sent two radios, 735 and this 2800. And the complaint with this radio is will not power up. So it's hooked to the DC supply, and when you mash the power button, nothing happens. Now, it's been a while since I've worked on one of these radios, but I have worked on quite a few of them. And out of 6 radios, 5 of them had the same problem. And I'm just sitting here wondering maybe if this one has the same problem. But unlike a commercial radio or a marine style radio, most of the radio is sealed, so no water can get into it. But the last few I worked on was actually water damage. So in this particular radio, the power button, is not a switch. It's just a tactile style button that grounds a pin to the main CPU, and that powers the rig up. And since this is not happening, we have to wonder just how far the voltage is getting. So you have to bear with me because it's hot out today. I do have the air conditioning running, and you can probably hear it in the background. So y'all just have to bear with that noise, because when I walked into the shop after work today, it was about 81 degrees in here. But it's a nice cool 73 now, just how I like it. So we'll go ahead and crack this open and see what we can find out with it. So to get into the radio, you got 3 screws on the front. We'll need to remove those, and the front panel pulls right off of it. And then there's some screws here on the bottom. This one plate comes off. Now this radio only has 2 circuit boards in it, the main board and the front panel board. So when we take it apart, you'll see that everything chassis wise will be removed. So I'm going to go ahead and get it cracked open and get the bottom cover off. Now that we have the bottom cover off, we'll have to remove this antenna jack to get it out of the way, and plus it is soldered directly to the board. So we'll need to lift the ground and the center pin off. As usual, it's very easy. The speaker just sits on the main board with this little piece of rubber with 2 knobs on it that fit directly into the board. So we'll go ahead and remove the speaker wires. And yes, so that you know, I'm still having a lot of pain and numbness in my hands and fingers. Day before yesterday, I'm getting lots of sharp pains here in my wrist. I did go back to the doctor and we'll follow up, and they are scheduling surgery. Let me move that vent so we're not blowing directly down on the camera with the air conditioning. I'm sorry about that. I do apologize. I should have already had that done. We'll move 3 of these Allen head screws out of the front of the radio. There's a lot of times when you get a radio like this that does not power up. There's many things that could cause this. One thing about these radios is that the boards are multi-layer, and sometimes traces in between the layers blow and are impossible to jump, and you have to wonder just how much someone would want to put in a radio like this label wise to go in here and try to find the area that's blown out, take a Dremel tool, cut down to that layer and bridge that blown trace. Okay, panel's removed. I'm going to go ahead and remove the main circuit board because we need to do a few checks, and we'll look at the schematic in a moment. I'll go ahead and get these screws out. They need a bore in all of that. Okay, that should be all the screws, and we'll have to make sure we lift up the power cord. As you can see, there's no gaskets, no nothing inside this ring. You know, the main board. There's no gaskets around the front panel. Also, even on this board, there's no gasket in the microphone or around any of the buttons. So any moisture that gets spilt onto this radio can wick right on into behind the buttons and all over the circuit board. Here is the main microprocessor, and we got 2 header pins that connect the front panel to the main board. And I missed a screw. They put quite a bit of screws in these. You hold the main board in. Alright. We'll set this aside. Go ahead and remove the silicone grease, just so that it's not all over the bench and all over me and everywhere else. And when if we can get it fixed, we'll apply some new before we put it in. So here we have the main board and the front panel. So if there's testing, we can test it just by mounting it back together, applying power. Now it's easier to get to everything. Won't be no problems of anything running hot. So let's go ahead and have a peek at the schematic. So here on our schematic, you can see where our power cable connects through here, and the main 13.8 volts comes in, and it feeds other parts of the radio. But here's a junction that comes up and goes to Q301, and we should have a constant 13.8 volts on the emitter of this transistor. You see we come down here to Q302, and this wanders on off and goes to our CPU latch connection. So when we press the power button, it sends the signal right on up here applies voltage to the base of Q301 and turns the junction on and lets the voltage flow right on into the 8 volt and the 5 volt regulators. So what we need to do is test and see what type of voltage we are having here. Now if I scroll on down, and we'll come over here, and this is the main CPU. Here we can see our power switch, and it's grounds on one end and comes down and latches DC 5 volts onto our microprocessor, and that's what starts the radio up. And that pin in question, I do believe, will be pin 18. Yes, that's pin 18 of the microprocessor. Okay, we'll go ahead and check and see if we got any, to make sure that we do have DC voltage on the main board. And we're at 13.7 volts. We'll stay here to ground and we'll come to the emitter of Q301. And we have 13.5 volts. We'll check our base. And it's also showing 13.5 volts. But there is no voltage on the collector of this transistor. So we are not getting a turn on. Since I only have 2 hands, I'll have to flip the ground lead on. And we'll go here to the base again. And we're getting no change. At all. So I'm gonna pretty much say that our problem is going to be in our front panel. So getting to our front panel, we'll need to remove all 3 knobs. And all you got to do is just give them a little start and they'll come right off. You'd only have to apply force so you're not going to damage the plastic. And we'll need to remove the 4 screws here in the back. Do not use no powered type driver on this. This is plastic. You can break the standoffs, and then that'll just be something else where you'll have to fix. Now here on the top we got this little metal tang here, and it's actually a little L bracket that will slide right out. Now you should be able to come in here and put your fingers on the 2 knobs and pull the board right out. And I'm already seeing the problem. Now as far as the LCD block, you'll see we'll have a block here. There's a zebra strip across. This is just a light box. And we have a diffuser and our LCD. So we'll just tuck them safely back into the front panel. And we'll go ahead and take a look at this board. Now, I don't know if you can already see it, but you can see right here we already have corrosion, And this is where liquid has come in through the yes, I can even see it on the keypad. You can see right here where liquid had come into the front button. It looks like probably soft drink or something, which is very acidic. And you can see that some of these membranes or conductive pads here are corroded as well. So this button is for our power button, and you can see there's a circuit trace that comes right on around, and it goes right up under this corrosion here. So I'm going to have to stick this under the microscope just to see how bad it is. Okay, we are recording live on both the laptop and the main vlogging camera. As you can see all the corrosion here. Right on, even down on this pad you can see the corrosion, so he's probably shorted together there. That's an LED here. It looks fine, but you can see all the corrosion has seeped out here. What you also see, if you look real good, you can see there's several vias around here. You can see there's a via here that's completely dark inside. There's one here, there's one here, and there's one there. And they supply power throughout the board. And let's see if I can move the board a little bit. We can see this via here has some corrosion in it, as well as this one. And you can also see that this pad for that switch is heavily corroded also. So the only thing I know to do is to go ahead and try to clean some of this off and see what can be done, if anything. We're going to try with some And one thing I have found out about this camera system, I have got to upgrade my video card. And it is also supposed to run on USB 3.0, and I'm running it on USB 2. Now a lot of that corrosion has come off, so I'm going to stop the camera just a second. Okay, I changed the resolution to see if that would help a little bit. Like I say, I have got to get in here and play around with this a little more. Well, I got all the corrosion cleaned off. As you can see, even that contact for that switch is good and clean. I used a little bit of Scotch-Brite on it, very fine Scotch-Brite. And you remember how corroded this one was also. So they're looking a whole lot better. So the only thing now I got to tackle is those vias and see if I have continuity from one side to the other. That'll be a little bit fun to play with, and until I get this camera system straightened out and get everything working right. As you can see, when I move, you can see how blurred it gets, and that's because of the video resolution. So that's something I've got to play around with to try to get straightened out and add a new video card. Okay, now that we got the front panel board cleaned, we still have to worry about those vias. The radio still doesn't power up, because the only thing we've done was clean the board. We haven't fixed anything. But the way this works is that this radio will always have VCC going to the microprocessor. Even if it's off or on, it's going to be some power going to it. And without that power, it cannot function. Again, we're looking back at our 13.8 volt input. And we see it goes through this ferrite bead here, and it comes down. You see it branches off to 2 caps. But this line goes all the way over. And let me go ahead and get you to this. But right here on the schematic, you can see this is the front panel connector. This is on the main board side, and then goes over to the front panel board, and you can see that our 13.8 volt comes down, and it splits off again in 2 different places. This is the side that we're concerned about here, and it's simply going to come right on down, and as it comes down, you see it comes to this diode D17. Then it runs on over and goes to this regulator. See that regulator there? And we'll come off pin 1 of this regulator, and we're going to have some filtering. And it's going to go right on into VCC of the main processor at about 5.03 volts. So what we need to do is check and see if this 13 volts is coming all the way through. Because without any voltage going to that processor, this radio will never power on. So we're looking at the board layout at J109. This is where the 13.8 volt is fed into it, and you can see the trace. It comes right up to R162, and what we don't see is where it branches off, because we know that this trace branches off and goes to 2 different circuits at R162 point. So there's probably a via there, and it's going off on the other side. But the thing that we're most concerned about is getting this 13.8 volts all the way over here to D117. From D117, it goes through it. It runs up through a via right here, and then it splits off and goes to the regulator that feeds the microprocessor. So the best way to check this to see if we're even getting voltage is to check here at D117 and see if we have 13.8 volts at D117. And again, looking here at the schematic, you can see J109 pin 4 is our 13.8 volts DC, and this junction right here is where it splits off. This line comes over and it goes to R162. That's not the side we're worried about. We have to follow right on down this line. Then it comes over here and goes to D117. So this is where we need to check to make sure we have 13.8 volts at J109 and at D117. And you can see it comes here and feeds this regulator. And from pin 1 it goes right straight on through the filtering to the VCC of the processor. Okay, this is J109. Pin 1 is ground. Pin 4 will be our supply voltage of 13.8. And I'll get the voltmeter over here. And we'll go ahead and always a glare. Alright, the glare is gone. And we'll probe J109 pin 4. and 13.62 volts. Now what I want to do is make sure it's going directly into the front board, and to be sure that we don't have a bad connection here on this header pin, we'll probe this and see if we got voltage there. And I'm going to have to get the mag light down here if I can see. Go to ground. And 13.6 volts. So we do have voltage going into the board. Now we want to test to see if we have voltage at D117. D117 is right there beside this capacitor. That little tiny SMD diode. So we'll ground again and we'll check and see if we have any voltage there. Okay, I had to position the mag light. I just cut it camera off so I can position that without y'all hearing all that squeaky noise. So we'll go to ground and we'll go to D117 and we have absolutely nothing. Nope, there is nothing, no voltage at all, which means there's no voltage being supplied to the regulator, which means there's no 5 volts going to the processor. So what that means, the only thing that is in between D117 and J109 pin 4 is circuit trace and vias. So somewhere around the line we have lost connection, and it's probably one of those vias that's eat out from the contamination that was on the front board. Okay, for test purpose only, what I did was a little barged here. And what I did, I added the wire to pin 4 and come right over and went through this via that in turns goes right up to D17, and that is actually the via that feeds D17. So I'm going to put the panel back in the front case and we'll power it up and see if we get anything. Okay, I got the radio back in the with the front panel back in the cover, and the reason why you have to do that is because remember there's a zebra strip in there, and you got to put all the bolts in it and the shield to compress all that together. We got power applied, and you're seeing this for the first time to see if this is a go or no go. We'll see if I failed and don't know what I was doing. So here we go. We're going to press the power button and see what happens. Oh, look at that. The radio now powers up. Now it's time to do the happy dance. But yeah. So I need to go in and see if I can repair those vias, and then we'll do some more testing on this radio, because we still got to see if it'll transmit, if it'll receive, if all the functions are working. But as you can see, she is now powering up, and that makes me very happy to see that. So yeah, as you can see, the corrosion had got into one of these, either the megahertz or the reverse button, whatever liquid that was, ran down on the board. It's gotten to the vias and has stopped power from going to it. And just to make sure that we're not fooling the processor, let me hit the power button. Yes, and it turns off. So yeah, you know, not a very hard fix. It's a simple fix just to get it back up and running. But you know, we could leave the barge wear on there, but I'd like to go ahead and find out and repair the via that's in there and keep the thing working like it's supposed to be. But I'll go ahead and get into that, and then we'll get the radio tested out and see what it does. I went ahead and pulled the microphone out of the box too, because I was going to better use it, you know, when I put the radio back together. And I don't doubt y'all can see that, but there's a lot of green in there, and that's corrosion also. I can see it a lot better under the mag lamp, so I know there's some corrosion in there. So I have to wonder if there's corrosion inside this microphone jack. Yeah, and I can see a little green in there also. So I'm going to try to clean that with some alcohol and see if that will take it off. If not, we're going to have to scrape it out, and maybe we won't have to replace this plug, because I do not have this plug in stock. I would have to order it. I do have the microphone ends. I think it's not an RJ45. I can't remember what they are, but hopefully we can get that cleaned up also. Well, after looking at that, I decided to leave that barge wire on there, and the reason was that it's actually two vias in there. That's the only thing that's on the line, and instead of taking a chance and burning up other traces that are nearby it, the barge wire will be completely fine. Won't be no problem. Like it is, it's out of the way, it's not hurting anything. Okay, so what we're going to do now is getting all this old heatsink compound off. Put some new compound on. Don't take a whole lot of it. I'll go ahead and get this bolted down. Okay, we have the radio all back together, less the cover. Have it on 146.52. We're tied into the IFR. We'll go ahead and generate a signal. We'll go to generate. And we can already hear that our radio is receiving. And you can see we have the generator just about all the way down. It's about a minus 124 dBm. Which is about 0.15 microvolts. So the radio is receiving fairly well. No problems at all. We'll go back into receive mode. We got it on 150 watts average. key the radio up. I'm showing about 20 watts on low power. That's high power. And we're over 40 watts on high power. So that looks pretty good. Go down here to peak. Yeah, about 50 watts on peak. So our little radio here is doing fine, no problems whatsoever, and it checks out good. Only thing I haven't checked out is the deviation. So I'll switch it over here to deviation. We'll go to 6 kilohertz on the meter. Test 1 2, test 1 2, and we're about around 5 to 6. Not bad. That looks pretty good. Don't want to go much over 5 on the deviation. So yeah, our little radio is turned out and is working good as it should be, and I've already checked the functions, and the functions are working just fine. So another radio saved. Well, I hope you found this little repair useful, and if you did, you can always show me by leaving your comments or giving me a thumbs up. That always helps. And as you see, it wasn't too hard to figure out what was going on with this radio. Like I say, after you work on so many of them for so long, you can pretty much diagnose it right out of the box. So the thing is now is to get this one cleaned up, get it boxed back up, and ready to go back to the owner. And he also sent in another radio for repair, and it is the ICOM IC-735. So I'll be getting on it before long and getting it checked out and find out what the problems is with it. Anyway, hope you enjoyed it. Don't forget to click the show more tab. I'll leave a link over to TheDefpom. You can check him out. I'll also leave a link to contact information and a link to this video on the website at www.gocarters.com/simple-machine-form, or SMS for short. And we'll see you in the next video. Have a good day now.